Hello everyone, and welcome to another data recovery episode. Today I want to show you how to recover a database that has been dropped. There are several assumptions you need to know before watching it further. First of all, I assume there is no usable backup copy. Second, the table should be InnoDB. MySQL and other storage engines are out of scope of this video, and you won't be able to recover tables other than InnoDB. Third, MySQL runs on a non-encrypted, non-compressed file system. The method I will show you works on ext4, XFS, and even NTFS file systems, but it will not work on ZFS or Apple's APFS. To make it more useful, I chose a scenario I see most often in real data recovery cases. It's a WordPress database, and MySQL runs on the root partition. This is not what I would recommend, but it is what most MySQL users do, and I'll have that set up too. My plan is the following. I provisioned a test MySQL server using a copy of the TwinDB website. The MySQL version is 5.7 with InnoDB file per table on. I will drop the database, then I will use the undrop for InnoDB toolkit to recover the tables. And finally, I will load the tables back to the server where the database had been dropped. This is my database server. It runs MySQL 5.7. There are several databases on this instance, including TwinDB. It's our example database. It's a copy of TwinDB website. There are some WordPress tables in here, a dozen of tables. These are real tables with real data. The tables are good as an example here because they have a variety of different field types, including interesting ones like date type and long blob fields. On the file level system, MySQL stores files in varlib MySQL. It is mounted on the root partition. I did it intentionally for the sake of this example, but in production I would recommend to keep MySQL files on a dedicated partition and mount it to the instance where you run the database server. Now let's drop the TwinDB database. When you execute drop database, internally MySQL drops each individual table, and then eventually when all tables are dropped, it removes the database directory. So it starts with FRM file and IBD file for each table, and in the end it deletes the database directory, which is TwinDB for us. Now, neither MySQL D nor operating system itself doesn't destroy user data when the file is deleted. It's still somewhere on the disk partition, but now it's a free space, and MySQL D, as well as the operating system, is free to reuse that free space for some other data. That's why task number one, right after you drop the database, is to preserve the original state of the database instance right after the drop database happened. Okay, so first thing you want to do is kill MySQL D. MySQL D may be doing some activity, maybe reorganizing table spaces, so it's better to stop all write activity on the root partition. You cannot stop operating system, and if if the database directory was mounted on a dedicated partition, I would recommend to unmount it or remount it read-only. But in this example, we run MySQL on the root partition, so we cannot remount it read-only. So what we're gonna do is try to stop all write activity on it. We will not install any additional packages. If needed, you may drop, you may kill some processes if you suspect that some of them may be actively using disk, especially for writes. And we will take a disk image of the root partition and save it somewhere on some other server. For that, I will use the disk copy utility, which is DD. It's an old Unix utility. It's available on probably every machine, and it does very simple job. It takes input file and reads the input file and writes the content to output file. We will specify disk partition as an input file. As output file, we will specify standard output, because we will pipe it to netcat, and over the network we will transfer it to a recovery server. I run this instance on AWS. This is EC2 instance. What is faster is probably to create a disk volume and mount it to the database server. In that case, you can copy the disk image from the root partition to a file on the mounted disk volume. That will be faster, that will be easier. You don't need to transfer data over the network, and you can do all work here. The recovery server is a separate Linux box, and it will accept the disk image. Then we will take a stream parser from undrop for InnoDB toolkit. We will parse the disk image with the stream parser. The stream parser will find InnoDB pages on the disk image. It will sort InnoDB pages by index ID. Next step is we will take those InnoDB pages that stream parser found, and we will use cparser tool that reads InnoDB page and extracts records from the InnoDB page. cparser stores user records as tab-separated values in text dumps. So we can use load data in file SQL command to import the recovered records back into the original database. So that's our recovery plan. Now I will show you that plan in action, and let's see if it works. On the database instance, we want to stop mysqld because it may be accepting some writes, and we don't want to overwrite the data that is on the free space on this file system. Now, mysqld used to use save mysqld safeguard process. Now on this operating system it uses systemd, so if I just kill it with -9, my systemd will restart mysqld, and I don't want to do that, so I will gracefully kill mysqld with the default sigterm process. mysqld exits gracefully when it receives sigterm, So we can see now mysqld is down, so there are no further writes. Now disk image is this device, and how I know that? Very useful command. If you run df on the directory that MySQL uses as data there, it will show you what device it mounted on this directory. So we will use disk copy tool. Input file would be the device name. Output file would be dev standard output. Block size can be any, but I will specify 16K. Now I will send this stream to the recovery server, which is on this instance. IP others, that is IP address of my recovery server. I will use port 9999, and on the receiving part I will need to start netcat as well. I will pipe it to PV tool to show the progress, and I will store the result in disk image file. Alright, the receiving part is ready, so let's send it to the recovery box. Okay, and now it's done. On whatever reason, netcat doesn't exit, so I will just kill it. Disk image is an image of the root partition of the database box. I will run stream parser to parse the image file. What stream parser does, it finds InnoDB pages on the disk image, and it sorts the pages by page type as well as index ID. Now I will run stream parser against the disk image and wait until the stream parser finds InnoDB pages. Okay, almost done. Well, done. Let's see what it has found. So we see two page types here. Index pages is where InnoDB stores user data, and page type blob is a page type for external pages. If a field value is too large to be stored in one 16 kilobytes page, then InnoDB will use this page type to store the remaining part of the blob field here. I know that WP posts table, it does have long blob, long text fields, so I expect pages of this type as well. Yeah, there are some. Okay, good. So in total it found a couple of megabytes of InnoDB pages. Sounds reasonable, taken into account that the TwinDB database is not very large. What do we do with the pages? The next step is to run cparser against the pages and extract records from it. Okay, so when we run cparser, we need to specify a file name with the pages, with the index pages, and we have quite a few of them. So which one is ours? I will need to recover InnoDB dictionary to get a list of tables that I need to recover, as well as the index IDs. There is a recovery dictionary script, but it expects directory with InnoDB pages in pages IB data. I will make a symlink. Okay. it couldn't find MySQL command because there is no MySQL running here, and I think it will be useful to have it. So let's install MySQL server as well as MySQL client on this instance. Okay, the database is up and running. Let's see if version 8 creates table database test. It doesn't, so I will create database test. The recovery script will create dictionary tables in the test database. So mysql conf d, mysqld. Okay, somewhere in here. Restart MySQL. Okay, we loaded the dictionary into the test database. Now let's see what we've got here. There are dictionary tables, recovered dictionary tables, and in systables we have a list of tables, and we see our tables in here. Okay, so these are tables that we dropped. Good, good. Now, for each table, we need to find index ID. So let me show you. So there is a table, wposts. This table has ID 45. It's a table ID. Now, if you run select from sys indexes, you will see the table ID. Let's add table ID clause, and let's say it's 45. So we see index IDs of the table wposts, and we see that there is a primary index and a bunch of secondary indexes. We need the index ID of the primary index because this is where the complete table is. Now let's write a query that will give us index ID by table name. We need only the primary, so we will sort, we will output only sysindexes ID. We will sort by ID and limit it to 1 because we need the lowest number. The primary index is always the lowest number. That would be our query to get index ID by table name. So let's write the recovery script. Okay, now we need tables. Now I want to make sure that that all index IDs can be found. Okay, there are index IDs. That's a good sign actually. But now we need a table structure. Table structure. There is a dedicated video how to get a table structure from different sources, including from the InnoDB dictionary. I will resort with a table structure that I can get from WordPress installation scripts. The most reliable way to get the table structure, the accurate table structure. Okay. I got the table structure from WordPress installation. I have created tables here. So what I'm gonna do now is write a script to prepare the table structure. What I need is each table in a separate file. So that's sh. Okay, now it looks more or less good. Let's see if we can use that. So for the posts table, our index ID was 58 as far as I remember. So let's try to recover this table. So -6. -6 or -4 or -5 option specifies records format of this in InnoDB page. And I specify -6 because it's a compact version, so it can be either 5 or 6. Both 5 or 6 are compact version. But -5 means versions before 5.6. -6 means versions 5.6 and up. The next is I need to specify a file with InnoDB pages. So it's a disk image, index, and that is 59. Now I need to specify table structure. So it's schema w posts, and for now it's enough. Let's see. Okay, few things to note here. First of all, it looks like it recovers a record correctly. So it looks like data, date time fields are valid. Some other fields are valid, so far so good. If you look at the beginning, so these errors mean that cParser tried to open external page and it couldn't because it was looking for it in the current directory, and our index pages are stored in other directory. They are stored in this directory. So let's try with that option. Okay, now there are no errors. That's good. And it's almost ready. So if we we need to save this table dump in a file. So let's create directory for the dumps, InnoDB. Okay, and we store standard output in the file with the same name, and standard error output we will store in a separate file in the SQL. And let's see what we've got here. So wposts is, let's open it in this screen. Wposts is a table separated values dump. Okay, so here we have like typical record would be this. So this is internal information, and this is where user data begins. So this is ID, this is next field, I think it's author, this is timestamp 1, 3, then other fields, and so on and so forth. So this is our record. Now, to load this record, we need a load data in file SQL command, and that command is stored in this file. Parse produces the valid load data in file command into standard output, standard error output. It lists correctly field names. If some fields need decoding, it correctly generates this SQL statement. It also tries to guess the file name with a dump, but if you look closely, it's not this file. It's root undrop dumps InnoDB, and then there is a file. So then we can fix this if we add the option P. And now if we look at the SQL file, we will see that instead of default, there is InnoDB, and the file name does exist. Now, why didn't I use default directory? It was possible for this particular case because there is only one database, and we could potentially put the table dumps and the SQL files in this directory. But if you have more than one database, it's just convenient to keep the table dumps separately, each on its own directory. And this is where -p option comes handy, because you can specify what database you recover and what table dump file it should generate. Okay, so this looks like our final command. So let's put it in our recovery script. Okay, looks good. Let's run it. Okay, let's see what we've got. Dumps, InnoDB, some records. Let's see some of the dumps. Okay, looks good. WordPress options also looks good. Posts, we've seen it already, not empty. Now I want to show another output that you can see in the SQL file. There is a recovery status in here. Okay, this I need to explain on the board. So let's say we have InnoDB page. It's a 16 kilobytes file. In the beginning of the page, there are two special records. The beginning of the list, Infinum, and the end of the list is Supremum. So InnoDB page stores records as double-linked list. The list has its head, which is Infinum record, as well as the tail, which is Supremum record. Physically, Infinum and Supremum are located in the beginning of the page. They are actually located at the fixed position inside the InnoDB page, and basically this is how stream Parse finds InnoDB page. This is one of the checks. But then in the remaining part of the page, we have user records. Infinum record stores a pointer to the next record, and Supremum stores 0 here because there is no next record for Supremum. So this is, we have some user record. Let's say it's 1. Let's say it has some value. Then we have next record, DEF, and so on. So these are logically, they are linked together, but physically they can be in different parts of a page. So Infinum record points to this record, to the first record, and this first record points to the second record. And so on, and the last record in a page, XYZ, it points to Supremum record. So this is how it looks physically. Logically, it's Infinum record, then 1, 2, X, and Supremum. Okay, so why am I telling you this? Because cparser, when it starts processing a page, it looks at these Supremum and Infinum records, and it tries to travel by pointers from the Infinum down to Supremum record. And if it can do so, then cparser knows that page is relatively in a good shape. So this list is complete, it's consistent. And cparser also knows how many records are expected in this page. And for each page, cparser can calculate number of expected records. So eventually, when it produces full output, it knows how many records were actually expected and how many records were actually recovered. So here you can see that cparser expected 246 records. It managed to read 246 records, and that means we didn't lose any records. So that's a good news. Also, if you look at the table dump, for each page you will see statistics per page. For example, this page number 8, it does have a valid record list, the list I was talking about, and it expected 15 records. Why 2 numbers? Because one of the numbers comes from page header. Page header contains number of expected records in this page. But also cparser travels from the infimum to supremum and counts number of records in the list. So it's also 15. In the end of the page, it prints number of actually read records, and if this number matches this number, then we don't lose any records, and we are good. Now, why cparser can read not all records? It is possible that a record is partially overwritten, and for example, some ID may have just wrong value, wrong number, or some date may have wrong value, or something wrong about that record in general. And in that case, cparser will just skip that record, and we will read less than expected number of records. So in this particular case, we were lucky. 15 records were read. We're good. Since we recovered the database, we have table dumps, and we can load them into the MySQL instance. We can create database again. Database InnoDB. So these are just create table statements that we can execute. We can execute them all together in InnoDB database. Show tables. So now we have them. And what we need to do now is load our table dumps. So how to do that? Actually, what we need to do is execute this statement, and that's it. But we have many of them, so we will execute all SQL files, and we'll load them in InnoDB database. Some value is not correct. That's interesting. So that was in a page in WP posts. Something is off with this value. It may be so it's written incorrectly, or maybe it was a corrupted record. In this case, I don't see anything bad with it. So I will just... date is obviously wrong, but the remaining part of the record seems to be valid. So I will just go ahead and fix it manually and execute it again. Okay, still zeros are not good. It's probably because of of this line 17. No, it's not this line. Okay. It's probably caused by SQL mode. So let's take this value, maybe it will. All right. No. Not that. Okay, how many? Just one. Okay. I will fix this value too. Let's try again. What is out file disabled? No, that's fine. Okay, there is some error in one of the SQL files. Okay, so it couldn't find some specific page. Oh, I see now. It actually couldn't find this index page, and that's why it couldn't recover this table. That's shame. So that's why we don't have any records. What can you do? Okay. So we lost one table. That's of course unpleasant outcome, but fortunately that table can be recreated, I believe, and important tables with user generated content are here. They seem to be fine. So we will assume that this is the recovered database, and that's the state of it that we managed to get after the drop database. So I hope it was useful. I hope it was interesting, and if you have any questions, let me know. If anything was covered not in enough details, let me know. I will try to elaborate, and I'll see you next time. Take care.